In this section, we're going to be concerned with the interpretation of probability. We saw that the probability of heads is not really representing some inherent uncertainty about the result of a coin toss, but rather our uncertainty about the initial conditions prior to initiating the tossing process. We're going to generalize this concept to arbitrary logical propositions. To help us in this regard, we're going to introduce a little bit of notation. So I'm going to use A and B to represent any logical sentence. And this is essentially a proposition about the real world that could be either true or false. And I'm going to allow any logical sentence whatsoever as soon as they are not contradictions. And I'm also going to use this symbol I to indicate all the information that I have at a given point in time. So this would include everything I know regarding propositions A and B. I'm going to be referring to this I as the information or the background information. I'm also going to use these shortcuts. I'm going to denote not A by this symbol followed by A. I'm going to denote A and B, which should be read A and B is true by either A comma B or A followed by B, which looks like A times B. And I will refer to A or B, which should be read as A is true or B is true, as A plus B. Alright, so how should we talk about probabilities? Whenever you see this symbol right here, you should be reading the probability of A being true, given that we know that B and I are true. And of course, assuming that I is implied, you can alternatively say the probability of A being true, given that we know that B is true. Or even simpler, you can say the probability of A given B. Let's talk a little bit about the probability of A given B and I. What does that mean? We're gonna assume that this thing is a number between 0 and 1 that quantifies the degree of plausibility that A is true given that B is true, and given that we know that I, the background information, is also true. And whenever you see this number being exactly 1, this means that you are absolutely certain that A is true if B is true. This is like logic, where you know that B implies A. So A follows naturally from B no matter what. If B is true, A is going to be true. This is what the first statement in the blue says. If, on the other hand, you see that the probability of A given B is 0, this means that you're absolutely certain that A is false if B is true. Now, if you get a number that is anywhere between 0 and 1, this means that you are uncertain about A if B is true. And if this number in particular is exactly 1/2, then you are completely ignorant about A if B is true.